Hey kids, Flexing Teacher Weber here. Hope you're having a good day. Last couple days you've been working on area of a parallelogram. Now today we're going to look at area of a triangle. So if you look at this first page, you do not see a triangle. You see a parallelogram, right? And remember, the parallelogram has a base, and then drawn straight up from the base is the height, right? We always measure height straight up and down. Now, a triangle is half a parallelogram, so the area of a triangle is base times height divided by 2. Now, check this out. How is a triangle half a parallelogram? Well, if I go to one of the corners of the triangle and draw a straight line from one corner to the other, look what you get. You get two triangles of exactly the same size. So I can also do it from this corner to this corner as well. And you draw a perfectly straight line, you get two triangles of exactly the same size. So since the area of a parallelogram is A equals base times height for a parallelogram, the math equation for area of a triangle is base times the height, or BH. Remember, we don't use the multiplication symbol. Base times height divided by 2. And we write that as a fraction. We write that as a base times height multiplied by the height on top and then divided by 2 in the bottom. So right there is the math equation for area of a triangle, because a triangle is literally half a parallelogram. So let's use this area calculation to answer some questions. I'm going to flip forward. So here we have, it says calculate the area of each figure. We have a triangle. And the math equation for area of a triangle is A equals base times height. You should always start off writing your math equation. I've noticed on some of your assignments we're not doing that, but make sure you do that. Base times height divide by 2. Now, in this triangle, the base is the bottom. So there's your base. And then the height is always measured straight up and down from the bottom. So the height of this triangle is 4. Remember, this dotted line is an imaginary line. I know this looks like there's two triangles there, but this dotted line represents an imaginary line. It's representing the height of the triangle. So the height is 4, and 7 is just the length of one of the sides. Okay, so I substitute these values into my math equation, working down the page. 6 4/10. Use parentheses to show your multiplication. Times 4. And don't forget, this is divide by 2. Now here's the interesting thing about this. There's a couple of ways I could do this. I could go and I could do 6 4/10 times 4 and then divide that by 2. But I could also treat this like a fraction, reduce some things first. What if I did this? What if I did 4 divided by 2 first? And then I'd be left with A equals 6 4/10 times 2. If I just went ahead and did the 4 divided by 2 first. And then I could do A equals 12 8/10 centimeters squared when I multiply the 6.4 times the 2. And don't forget, I've seen so many people forgetting to put their units squared on the end. Don't forget that. Now, if you didn't want to reduce first, you could go ahead and do 6 4/10 times 4, get your answer, and then divide that by 2, and you would get the exact same answer. But it's important you take your base times height and divide it by 2 for a triangle, because a triangle is half a parallelogram. All right, let's do another one. I'm going to flip forward. Okay, in this question we have a triangle. There's no dotted line in this triangle because this is a right triangle. This is a triangle that has a 90-degree angle in it. A 90-degree angle is an L-shaped angle. And that means if it's got a 90-degree angle, that means this distance right here that I'm outlining represents the height of the triangle. Because it's a straight up and down distance because it's at a 90-degree angle. And so that would mean this is the base of the triangle. So I write down my math equation. A equals base times height, divide by 2. A equals 12 multiplied by 14, divide by 2. Now, I could go ahead and do 12 times 14 first, and then divide that answer by 2, and that would be just fine. But you don't have to do that. You could do 14 divided by 2, or you could do 12 divided by 2, and simplify this fraction first. So I think I'll do 12 divided by 2. So 12 divided by 2 is 6, so I'm going to have A equals 6 times 14. Okay, and then let's see if I can remember some mental math here. 6 times 14, I'm going to do 6 times 10 first, which is 60, and 6 times 4, which is 24, which means the area here is going to be 84 centimeters squared. And you would get the same answer if you did 12 times 4 first and divided by 2, or if you would have done 14 divided by 2 and then 12 times 7. Either way you slice it up, you're going to get 84 centimeters squared. Make sure you're showing your work just like I'm circling right now. I want to see the solution shown just like that. All right, let's take a look at another one. No diagram here. It says calculate the area of a triangle with a base of 5 8/10 centimeters and a height of 7 centimeters. So it gives you the base and the height. I'm going to start off writing the math equation for area of a triangle. Base times height, divide by 2. And then area equals, the base is 5 8/10. The height is 7, and that's divide by 2. Now I think I'm going to do the multiplication first this time. I'll do 5 8/10 times 7. So A equals 5 8/10 times 7. When I work that out on scrap paper, I end up getting that is 40 6/10. And I can't forget that I still have to divide that by 2. And when I divide that total by 2, I get area equals 20 3/10, and that's centimeters squared. Okay, so this time I decided to do the multiplication first and then divide that total by 2 because it didn't look like there was going to be anything that would easily be simplified first. Yet another area of a triangle question. Let's do one more. I'm going to flip forward. This is not a triangle. It looks like a cool spaceship or something that I might have played with when I was a kid. It's not a triangle, but I bet you could see a triangle in there. So this is another one of those composite area ones where we have a couple of shapes. Now, could you divide this up into simpler shapes? Absolutely. What if I did this? I'm going to see this spot right here, and I'm going to make an imaginary dotted line. That's not a very good dotted line. You know what? I'll just make it a solid line. There we go. What if I divided it like that? Now I have a rectangle and I have a triangle, and since I drew this line straight down, this is going to be at a right angle. So that red line that I drew straight down is going to represent the height of the triangle that I made. So I'm going to divide this into parts. I'm going to call this part A1 and the triangular part A2. So I have a rectangle and a triangle now. Now the rectangle, I need a length and a width to calculate the area. Well, the length is 6 2/10. The width is 3 6/10. So there we go. I can calculate that. I'm going to write A1. Oh, I'm not going to. There we go. A1 equals length times width. A1 equals 6 2/10 times 3 6/10. A1 equals, it equals, when I work that out, 22 32 centimeters squared. Okay, now to get the area of the triangle, I need to have a base and a height. Well, the base of this triangle is going to be that distance from there to there. I don't know that distance, but I do know that from here to here is 8 4/10, and from here to here is 6 2/10. So if I do 8 4/10 and subtract off the 6 2/10, I'll have this little distance right here. So 8 4/10 minus 6 2/10 gives me a base of 2 2/10 centimeters. And then for the height of this triangle, I know that this length is 3 6/10, and this length then must be 3 6/10. So that's 3 6/10 centimeters. Now that I know my base and my height, I can do the area of the rectangle. I'm going to say, or the triangle, pardon me, area 2 equals 2 2/10 times 3 6/10 divide by 2. Area 2 equals 7.92 divided by 2. Area 2 equals 3.96 centimeters squared. So now that I have A1 and A2, I can do the total. To get the total area of that shape, I add up 22 32 and I add on to that the area of the triangular part plus 3.96. Add those up. 2 and 6 makes 8. 3 and 9 make 12. Carry the 1. Don't forget about the decimal. 3 and 2 and 1 makes 6. And 2. And don't forget about centimeters squared. So another example where you use the area calculation from a bunch of simpler shapes. We calculated the area of a rectangle. We calculated the area of a triangle. And then we added up those two totals. So I'm going to give you an assignment today on calculating area of a triangle. Do the questions just like I've outlined in the examples. Flexing Teacher Weber, out.